Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. In free radical chlorination, the reactivity of CH bonds depends on two factors: 1. Stability of the radical formed at that carbon, and 2. Inductive electronic effects of substituents. Fluorine is a strongly electron-withdrawing group, EWG, by induction, which destabilizes adjacent radicals by withdrawing electron density. Moving on to the next step. Identify the positions. Position A, CH3, terminal methyl, primary CH, 3HS, farthest from F. Position B, CH2 adjacent to CH3, internal primary secondary to HS, beta to F. Actually, this is the second carbon. Position C, CH2 next to CH2F, secondary to HS, beta to F. Position D, CH2 directly attached to F, to HS, alpha to F. Moving on to the next step. Assess radical stability at each position. All interior carbons, B and C, are secondary carbons, so they form secondary radicals, which are more stable than primary radicals, at or D. Position D, alpha to F. The fluorine directly attached to the adjacent carbon strongly destabilizes the radical at D through inductive electron withdrawal, making D the least reactive. Position A, terminal CH3, primary forms a primary radical, less stable than secondary but not destabilized by F. F is 4 carbons away, negligible inductive effect. Position C, beta to F, secondary carbon, but mildly destabilized by the inductive effect of F, 2 carbons away. Position B, gamma to F, secondary carbon, very little inductive destabilization from F, 3 carbons away. And for the final step, rank reactivities. B, secondary, gamma to F, least inductive destabilization among secondary, highest reactivity. C, secondary, beta to F, slightly more destabilized than B, second. A, primary, far from F, minimal inductive effect, third. D, alpha to F, strongly destabilized by F, lowest reactivity. Order B, C, A, D. Why other options fail? A, B, C, D ignores that B and C are secondary carbons and more reactive than primary. A, B, C, D. A places D above A, but D is alpha to F and strongly deactivated, so D should be least reactive. D, C, B, A, D reverses B and C. B is farther from F and thus less destabilized, making B more reactive than C. Therefore, the correct answer is C. Therefore, the correct answer is option C.